Hello there, welcome to Computer Science on Video. So exciting for you. I have, let's see, pull this up to the top. I'm working on 4.1, so Chapter 4, Section 1, so you'll want to make sure you download that. You can pause the video if you need to get that set up. Then we are looking at the while loop today. And a loop is, let's talk about it, when you would want to use a loop would be anytime you have steps that you need to repeat. So I'm going to do this, 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 and this, and then I'm going to start over and do those things again. So anytime you have a series or a group of steps that you need to repeat. And that is when you would want to use a loop in your code. And we have that very often. And how to use a loop, that's a little bit more complicated, but there are several types of loops, and we're going to look at them all in Chapter 4. And the first one that we're going to look at is the while loop. So the while loop. And we'll look at how you can use the while loop, and while we do that, we'll learn more about loops as well. So look at the pseudocode below, and it says pseudocode colon, there it is, for calculating how long it will take for $10,000 to double if you have it in an account earning interest. And we're using compound interest, which is what the banks use, and we're going to assume that for this exercise that the number of compoundings is 1, which corresponds with annual compounding. So it's going to be something like a savings bond or a certificate of deposit. Those use 1 annual compounding. Then we'll use a rate of 5% interest or 0.05. And we'll have a starting balance of $10,000 because we were wanting to know when $10,000 would double. So to do that, our pseudocode says, repeat the following steps while the balance is less than $20,000. So if we can write a statement like that, that is a perfect place for us to use a loop. So this means we need a loop. Anytime you're going to say repeat or start over at number 1 or anything like that, that means you need a loop. Okay, so first thing we'll do is add 1 to the year, and then we want to compute our new balance, and then after the loop, we will report our year as the answer. And so using a while loop, here's how that code would look. We start off and declare a couple of constants. One of them is our starting balance of $10,000, and the other is our target balance, which is what we want to end up with. And remember, that was doubled for the original account, so we'll just take the original balance times 2. So if we want to change that $10,000 later and check out how long will it take $20,000 to double, all we have to do is make one little change right here, and it'll automatically adjust our target to a doubled value. And so that's the benefit of using a calculation here in the constant declaration. Okay, so then the first thing, this is the format of a while loop. Here's the first line, it's while, and look at how it looks just like an if statement. If I just took out this while and put in if, it's just the same format as an if statement. We have if, and then we have a condition that we're checking, this squiggly, and it's ending squiggly down here. But remember, we didn't want to just check if, we wanted a while, so the format looks the same. While balance is less than target, start your loop. And then we're going to increment year, we're going to calculate our balance with interest, and this we're just going to comment out for now, and we'll talk about it in a minute. And then when we end our loop, we'll need a space // and this will be our end while, so it's the end of our loop. Then we will next print out how many years it's going to take for our investment to double. Okay, so we have several compiler errors because you know we learn a lot by figuring out what's wrong with our code. So here it says balance cannot be resolved to a variable, and we're looking here at balance. We haven't declared that anywhere, have we? So we need to put that in. That can be int balance. And it has to start out at something because we're checking it against target. I think we need to set that one to starting balance, because that's going to set it up initially to be $10,000, and I don't know that int is the right number because we're going to be calculating interest and adding it to that 10,000, so we might have some pennies in there too, so maybe we need to have that as a double. So balance needs to be set out initially to starting balance, and then we're going to check if balance is less than target. And our target is starting balance times 2. I maybe need to make that a double too, but we'll see. Right now I think I can do is a double less than an integer, and let's see if that works out. Then I'm adding 1 to the year. Remember, this plus plus takes whatever the variable is before it and adds a 1 to it. So year plus plus, but I have to define year, and that I believe is going to be an int because we're just calculating by year, and it should start at 0 because the first thing we're doing is adding 1 and saying, okay, a year has gone by. So we're getting closer. Next thing, the balance times equals and 1 plus rate. So times equals, remember that means balance equals balance times the quantity on the right, which was the rate, 1 plus rate. Put it in the right order. Like that means the same thing. Remember, it's a little bit shorter way because I don't have to repeat balance over here on the right hand side. I can just take this operation I'm doing with it, put it right before the equal sign, so times equals instead of equals balance times. Same exact operation. You can write it out long form, that's fine if that looks better to you. I just want you to get used to seeing it short form, because as you work with more experienced programmers, you're going to see that they use these little shortcuts because it's quicker to type. And so we're a lot faster at putting the code in. We can get to testing a lot quicker that way. We still have an error. Let's see what it is. Rate cannot be resolved to a variable. Oh, so we put rate down here, but we didn't define it anywhere. And rate we were going to leave as a constant because we were going to have it at 5% each year. So we should put it as one of our constants, so we'll put it after this one. And rate, 5%, that's going to be 0.05, so I'm going to need it to be type double. And probably also final, because I don't intend to change that in my code. Rate equals 0.05. And a semicolon, and that's going to be 5% interest. Okay, now rates define it. Looks like I got rid of all of my red X's. That's a good thing. And then the last thing is that I'm printing your investment of %D, so it'll tell me what starting balance, it'll put starting balance there, doubles after %D years, and it's going to print out year. So it looks like we're following our pseudocode. Repeat the following steps while the balance is less than $20,000. Okay, while the balance is less than our target, which in this case should be $20,000. Do you see how that translates directly into a line of code? If I'm thinking about, if I can word the question using while, then I can write it as a while loop. And the while is the condition is checked first, and then the things underneath loop until your exit condition is met. And our exit condition here is going to be if the balance is greater than or equal to the target. All right, let's run it and see what we've got here. And it'll help if I make my space a little bit bigger. It says your investment of $10,000 doubles after 15 years. So, well, that's nice, 15 years, but I'm kind of curious what's happening inside this loop. And that's where this system.out.printf is going to help me, because I can see each year it's inside the loop. So every time it loops through on that while loop, every time it goes through, it'll print out a statement for me. And so this is a method of debugging so that you can see what's happening in your loop, and it's a lot more satisfying than just a final answer, which we're not even sure if it's correct. So let's do a run now. Oh goodness. See what my output is doing? I'm missing something. I'm missing a /n, and I'll put it at the end of my line. Remember, it's very polite to put that on your last output too, so that when someone calls you your method that you wrote, that it doesn't leave them hanging on the end of a line of text that you output. It puts you down to the start of the next line. So we want to do that there, and it looks like I also need to do it on the very last print that I do. So \n, put that in, and I see another problem. Do you see this? This is my money. It shows that I have 10,500 is the value after 1 year, but then it has a ton of zeros after it. And we are talking about money, and that typically only has 2 decimal places. So I can come up here where I'm saying not how many years, because that was fine, but how many, the balance actually. And so where I have the balance, I want it to have 2 decimal places. So remember, I could give it like 6.2, and that would give me at least 6 in front of the decimal and then 2 after the decimal, or I could just leave off that 6, that's fine, and then it would just give me 2 after the decimal place. So I can do that. Let's look if I need starting balance. Is not going to need that, right? Okay, let's run one more time. Yay. Okay, so now when I look at my output, keep that on the screen, I can see for each year what's happening with my account. The value after 1 year, and it should say year, is $10,500.00. Now there's also a way for me to put a comma in there, and here where it's printing things out, in right before that decimal, it says %.2f, and I can put it to be %, .2f, and let's just try that, and we'll put it on both of them. The other one that has a big long number, and this one's %d, and so I could put %d. Now I don't have any red X's here, so I'm going to run it one more time and see what it did to my output. It made it have a comma in the, after 3 decimal places over. So that's like a super quick way to get your output to look really snazzy. So now I can see easily it's $10,500. The value after 2 years, it goes up to $11,025, and so on. And so I can see each year the value getting bigger and bigger. In year 15, so if I'm looking through my code, I'm starting off, year goes plus plus, so it was 14, it becomes 15. I calculate the amount of the value for my account in this line, so balance gets updated. I'm going to print out what my current balance is for that year, and that's where I get that the value after 15 years is $20,789.28, and before that it was underneath 20,000, so it was lower than 20,000. But this time through, when I'm on my time through where year becomes 15, I calculate my new balance, I print out the new balance, and then this little squiggly says go back up, and it's going to come right back up to here to loop. So it's going back up to the top to loop, and it's saying while balance is less than target. But now my balance, which is $20,789.28, is greater than target, and so it is going to drop out of the loop, which means it goes down to the next thing after the bottom of the loop. So that's why I need that squiggly there so it knows where to go. And so then it goes right to there and it starts executing from that point. Now I want to show you a couple of things with this, because we're going to really inspect how this loop thing works so that I can make sure you get a really good idea of what we're doing here. Here's a flow chart of what's happening. We can see that the control is coming, starting down this way. We check, remember that was the while balance is less than target. If the balance is less than target, that's the while condition, so we have true that is less than target, then we're going to do these things. Increment year, calculate interest, add interest to balance. And I did these two in one statement. And then the control comes back around and up to the top right before this while check, and it's going to come back into the while check. And as long as this balance is smaller than the target, which in this case was 20,000, it's going to keep going through here. It'll keep going and going and going until balance finally gets to be bigger than target. And once that happens, it's going to drop out, come out this side to the false end, and pick up from whatever comes next in the code. Okay, that's how the flowchart looks for the while loop. It has the check to see while this condition is true at the top, and generally we'll put the true down below and put the activities or statements that have to happen after. We know we're still less than our target in this case, with the loop coming back up to the top and returning to the while, because that's how the code actually works. And then the false part coming out, see how it comes out and comes down, but it doesn't connect with that the check that we were doing to return to the start of the loop. It's just going to come down after the loop and continue executing from there. So we know that we start the loop right here where the while statement is, and we are going to continue executing just from here to here, between those two squigglies, while the balance is less than target. So that's how you get into the loop, is you just run into it. It's the first thing in our code here, and then you keep looping until balance becomes bigger than target. So obviously, if we're looking for balance to be less than target to keep us inside the loop, we do need to be doing something with balance inside the loop, or we'll never get out of the loop. If balance isn't increasing, we will never exit from this loop. Okay, let's see. And then how many times will we go through the loop? You can figure that out. I wanted to show you the book again. We can trace through our code, and here's the code in the book, and it's doing this trace for us. So we'll just look at it because it's written all pretty. The first thing that happens is we check the loop condition. So before we even can enter the loop, this condition has to be true. So that has to return a true statement. And in our case, we're starting with a balance of 0 and a year of 0, or balance of 10,000, a year of 0. And so when we come here, balance is definitely less than 20,000. Then that will get us into the loop. So first we check the loop condition, and then we're going to execute the statements that are inside the loop. So these three in red, the adding one to the year, they did their calculation a little differently than what I'm showing you. I did it all in one line for the next part. But we have balance 10,500, year becomes 1, and then the interest we actually added in already. Then we go back and check the loop condition. So starting off with a while loop, we check the loop condition at the start, and then we execute the code if it's a true statement for the loop condition. Then we go back and check the loop condition again, and then we'll keep going through as many times as we need to. So we can see this number 3, we go through the loop again, or we're checking the condition again, and we run through all of those 3 statements that we have. And finally, after 15 iterations, we kind of talked about that. Our balance is $20,789.28. Our year becomes 15 once we run through here. The condition's no longer true, but we haven't gone back to check it yet. So we've run through this part of the code, and then we go back up and check the condition, and okay, it's no longer true. Then we bounce out to the statement after the end of the condition, or after the loop. So there's the loop start and stop, and here's where the next statement is. And so we bounce down to that one, and that's where we got that final printout. Okay, a bunch of ways of looking at that same loop, and I also put in what the book is showing you there is kind of a hand trace, so it's showing the value of each variable and what's getting executed. what I did to simulate that, and something that you can easily do, is just put a print statement inside your loop. And what I'm doing is saying the important things, the things that are being changed inside the loop, the number of years, and the balance. So I'm showing each of those so I know how many times I've gone through that loop. Okay, so that's the flow chart. The formatting, I showed you those already. Be careful where you define your variables. So for example, if I define my year here, instead of up here, let's just change it. What do you think will happen? Inside my loop, every time it executes through the loop, it's going to start over with a new variable called year. So it's deleting the old one and starting fresh. So I'm going to guess when we run this, we will never get out of the loop because year is never going to increase. And here, let's see what our error is. Oh yeah, they don't want us to do it that way. We'd have to set it up. And it'll let me do this, but it's not going to work. So that's the thing about programming. You have to figure out whether it's working or not. If I redefine year after every time I enter my loop, it's always going to start out at 0. And so I'm adding 1 to it. So my value for year is always going to be 1. And then let's see what the problem is here. Year cannot be resolved to a variable. That's the other issue. I've defined it inside this loop, so when I bump out of the loop, that variable doesn't exist anymore. So remember how I told you in the world, sometimes we will say as a programming group that we want all the variables to be defined at the top of the method instead of embedded throughout as you use the variables, and that's to avoid problems like this. So we know we want to use year inside the loop and outside, but if we only define it inside, we're going to have 2 problems. One is our value is never going to get bigger because we're going to keep figuring it out to be 1. And even if I comment out this line, it's still going to give me problems because it's saying, you might not have set a value for that. So it has many, many issues with what we're doing here. So we will have to define that year outside of the loop, and we can just do a + on it. Or you could type it out. Remember, year ++ is the same thing. Year equals year +1. It means the same thing. You can type it out if you want. And there I define it up above. Now year is defined for everything below it, and including the loop. So inside the loop you can use year, and down here after the loop you can still use year, and it'll still have the value that you got for it in the loop the last time through. So that's why I say be careful where you define your variables. It'd be probably smart for you to define them all outside of loops and outside of if statements. That's going to give you the best results. And we looked at some hand tracing. On 142, we did it using print statements. What's going to happen if we change balance to balance is less than or equal to target? And that's on this check right here. Do you think it'll change our execution? Let's try it out. So put an equals there, and then let's run it. Came out the same thing, and look at, here's why. Because it didn't come out exactly equal to the 20,000. It was over. So the equals part didn't make any difference when I did my check. So you could have it either way. We were just saying, oh, let's only loop when it's less than. That's fine. It'll also work less than or equal for this particular loop. Okay, so we got that. No difference. Because the balance was greater than the target. And I'll put that on the second line. Okay, Now, I want to know how long, so it was great, I know it's 15 years to double my investment. How long is it going to take me with the same interest rate, the same type of compounding, which was annual? How long is it going to take me to triple my investment? Let's look back. Do I have to make a big change here? I want to triple instead of double. So my final balance is going to be 30,000 instead of 20,000. That's my target. Yeah, all I have to do is change this to a 3, and it should work for tripling. And then instead of saying doubles down here, I can say triples. Okay, let's run it and make sure. Should be more than 15 years, right? Because we know 15 was for doubling. But it only takes 23 years to triple. So that's the beauty of compound interest. It has exponential growth. So when you put money into a compound interest account, the longer you leave it there, the quicker it gets to double, quadruple, and so on. So that's kind of cool. So, but it was a little over again, but it did take 23 years. So we can see here, we can scroll back and see the value for each year. First 15 years should match what we've already done. In fact, we can look at 15 and see that we have that same $20,789.28. That makes sense to me because we didn't come up with a new formula or any new values. We're just looking for a new target value. So there we go. That's how long it'll take to triple, 23 years. And there are some examples of while loops at the top of page 144, so I'm going to pull that up for us and talk about those briefly. So we have, I would like you to look at these on your own and think about them, but I do want to kind of give you an overview. This loop on this line here starts with your counter or your I is 0, and your sum is 0, and it's saying while your sum is less than 10, increment your I, which is your counter, and add I to your sum. Okay, and then print both of them while you're still in the loop, and then you're done. So here's some sample output that it's going to give you, and you're printing I and you're printing the sum. And so when the sum is 10, the loop condition is false, and the loop ends. And so when sum finally gets big enough, then it's going to drop you out of this loop. And so when you're, we'll do that in a minute. Here's another loop. This one is the counter and the sum are both starting at 0, just like up above. We're still checking the same check when sum is less than 10. Here we're doing we're incrementing it, we're making it bigger, and then the sum is having the sum minus I, and so the sum is getting smaller, but we were hoping the sum was going to get greater than, or less, we're going to continue looping until it gets bigger than 10, and it's not going to because sum is decrementing every time. And so we print both of the numbers, and here's what our output looks like. Sum is the right-hand one, and it's getting smaller and smaller every time. And this is one way you could run into an infinite loop. It will never exit the loop, and you'll have to do Control-C or run the code again. Okay, so here's some other possible things that can happen when you're looping. This one, same setup, I is 0, sum is 0. We're looking when sum is less than 0, and here, so we're subtracting, and then we're going to print I and the sum. But what happens, it says no output, and what happens is it's checking while sum is less than 0, but we're setting it up to be equal 0 right at the start, so we never even can execute the loop, so we will not get to the print statement ever. And so the statement sum is less than 0 is false the very first time through. So that's the problem with this one. So here's another one to look at. Same setup, I is 0, sum is 0. Still, now we're checking if sum is greater than or equal to 10. And so we want while sum is greater than or equal to 10. And when we're starting here, sum is starting at 0, and while sum is greater than or equal to 10, It's not. It's 0. It's much less than 10. It will never execute this loop either. Okay, here's another one. Sum 0 and I 0, while sum is less than 10. So sum is less than 10. Sum is 0. So we are going to get in here to execute. Oh, I see. I thought we would get in here to execute, but there's this minor problem here of a semicolon on the next line, or on that same line with the while, which is telling the computer that just loop right here while sum is less than 10. So it's going to continue doing basically nothing for infinity. It will never stop until you terminate it because it's stuck right here. So do not put a semicolon after your condition. Remember how on the if condition, and then we do the squiggly to start. If you put a semicolon there, it will just keep looping on that semicolon because it's never going to increment sum, and it's never going to get out of the while check there. So don't do that. It's legal, but it won't do what you want. Okay. All right, so when you're designing a loop and you want to use a while loop, your question needs to be worded with a while in it. So you would say something like, how long should I keep going through this loop? Or you can say, keep looping while, and then this is where you would put your condition, is true. And if you ask yourself in either of those two ways, or state how often you want to loop in one of those two ways, you will have it set up with your condition check will be set up correctly for a while loop. So it's easy to get the conditions backwards, and then you don't go through the loop as many times as you need to. So these two questions should help you. Okay, we looked at infinite loops. That's when you don't exit the loop and continue until the program is terminated. And then there's also a problem called an off by one error, and that will happen so some causes of infinite loops is not updating the variable that is used to exit, used in the condition. I kind of put that backwards, didn't I? So used in the variable that's used in the while condition, maybe you aren't updating it and it's checking that, or you could be incrementing instead of decrementing your counter. You could be decrementing instead of incrementing your counter. So you're expecting your counter to get larger. That's what you're checking for, but you're actually making it smaller. So that's one way you could get stuck in an infinite loop, or vice versa. And then off by one errors, that can happen when you don't go through the loop quite enough times, like one short of what you need or one too many times. And so you can kind of check that by figure out your test cases. Before you start, and use them to help you And then also using the print statements. That'll help you debug the loop too. Because if you're going one too many times, you'll see it when you do a print statement for every time you go through the loop, so that'll help you figure out if you did it right or not. Okay, your assignment, same thing, you have a regular level and the maximum score is 82%, and you have some challenges to get a maximum score of 100%. And so the regular level, you're going to write a program that uses while loops to do 2 of the following tasks. And so you can choose which 2 of these 3 tasks you want to do in your code. Print out all the squares less than n. Print out all positive numbers that are divisible by 10 and less than n. And so you're going to have to ask the user for n. That's the user input. And then you'll just do these, you'll do a loop for number 1 if that's one you choose, do a loop for number 2, and then you're finished for the regular level. Okay, print out all powers of 2 less than n, that's your third choice. And then here are a couple numbers to check. And I would check 64 and 65 because to make sure that you're handling the less than n part correctly. So it's less than, not less than or equal. So be careful of that. And then the challenge level. So if you're ready for a challenge, do all 3 of these tasks and format your output to skip to the next line after 10 numbers have been printed, and use tabs and output formatting so your columns line up. And then check your work with 1,000 and then with 10,000 to see if your columns line up. So 2 things that you need to do for the challenge level. Also definitely look at my sample output so that you can make sure that your numbers that you're printing out are correct, and then also just to get a look at how I'm printing them out, what the formatting I'm using is. And that's for both levels, for regular and challenge. Take a look at the output. All right, that's it for today. Have a good weekend.